This is the review for the second part of our Statistical Studies unit, Unit 3 in AQR. It's AQR 4.1. It's the first test we have for the second semester. And I'm going to go ahead and get reviewing on this information. Understand this is just a brief view. It follows very closely with what we have in on the test. But I just want you to understand that you are responsible for all the material. So I would suggest you do a little bit of review on your own so that you understand that some of the test questions may be a little different from the questions that are on the review. Unlike many of the tests in the past, this review does not cover all the material. It just covers a brief amount of the material. And there's a lot of material that we covered just in the last 3 lessons. And that's all that's on this is section 8, 9, and 10. 8 and 9 were the first review we did, or the first lessons we did in one day. And then 10 is the lessons we did at the end of last week. And of course, this test is over just those 3 lessons. So let's look at the first question. What are some ways that questions and surveys fail to capture the information needed accurately? Okay, if you go back and you look at your presentation, which I'll give you a copy of, you'll find this in like the very first section. So the design of a survey is important for capturing information. This is, so what are some ways that surveys fail to capture information needed accurately? Design a survey so important because the design of survey is so important for capturing information needed accurately. Pilot surveys are often conducted. Pilot survey is used with a small number of people and then analyzed to look for the following. These are the reasons why we have issues with surveys and how they fail to capture question ambiguity, leading questions, too many people choosing other or no opinion, and other data collection points. So let's go back to that, the review itself. And as you can see, that is the answer. I don't know if you realize this, but all I did was highlight the answer and change the color of it so you couldn't see it. There you go. These are the problems that surveys have. All right. So let's look at this. A survey company calls multiple households and asks which cable broadcast network they prefer. Nearly half did not answer or hung up. Now, what is this phenomena called? We call this non-response bias because the participants that we expect to answer actually don't respond. Okay? So it's kind of important. Dadgummit. I'll have to erase that. A player on the team notices that a coach from a regional D1 school is in the stands watching the game. He decides to listen to everything his coach tells him and pays careful attention to the flow of the game. What I forgot to put in here is that this player is typically doesn't listen to the coach, but he changes his attitude. What do we call it when there's someone watching someone doing something and they change their attitude? Believe it or not, that's actually called observer effect. It happens because the person's behavior or the way they act is changed by the fact that there's an observer there. Maybe because they want to impress the observer. In this case, that particular athlete is hoping to impress the recruiter. All right, so let's look at the next question. The district manager surveys all of his managers on their level of satisfaction with the proposed compensation package. It then reports the results to the corporate office in a graphical display. He titles the display as corporate satisfaction of the proposed compensation package. Okay? What is the problem with his report and what effect does it have? All right, so let's look at what he's done here. A district manager. He's not the corporate manager, he's the district manager. So in other words, he only manages a portion of the corporation, one district of the corporation. So as you can see, obviously his district may not fulfill the obligation to find the entire demographics of the entire corporation. So that kind of makes a little bit of a problem. So what we call that is it doesn't represent the entire corporation. It just represents his district. So we can call that a non-representative sample of the corporate employees, okay? So that makes sense now. That's why we call it non-representative. It doesn't represent the demographics of the whole corporation. It just represents the demographics of his district. All right. So this next survey question, we need to see what's wrong with it. I support sports program. Agree or disagree? Of course, this question is designed poorly. What about the statement gives it a poor design? I think you can figure this out. If you look at the first answer to the first question, it's the very first thing. Question ambiguity. It doesn't give us any details. It's not very clear. So that's the answer to that one. That makes total sense. If a question or some statement that you're asked to respond on some kind of survey is not very clear or doesn't give very many details, it's too ambiguous to give a good answer, okay? So if you're going to design a survey, it's very important that you try to remove as many ambiguous questions as possible. Make them as clear as possible so that you get the answer you're looking for. You want data that's relevant. Irrelevant data does not help a survey. It does not help the data that you collect. The data you collect don't give you anything if questions are so ambiguous that people don't understand what you're trying to find out. Actually, your participants don't need to know what you want to find out, but you want your data to be accurate. You want your data to be integral. In other words, it can't be just, based on certain information. So I support sports programs. If you're designing this particular question or this survey and you want to know about one specific sport like tennis, in my case, I wouldn't ask about supporting sports program. I would say, I would ask several questions about tennis and about whether or not a person supports the tennis program at Rudder High School. And that would make more sense. Okay. All right. Next question. Bias is a measure of how accurate of a sample of data is compared to the population. Remember, a sample is just a portion of the population that's supposed to represent the population. Variability is a measure of how precise a sample of data is compared to the population. True or false? Now, this is part of section 9, the second lesson we learn, and part of section 10. Let's think about this for a second. Bias is a measure of how accurate the sample of data is compared to the population. In other words, if the bias or if the results, the data results of an experimentation or some observation is made, and the results from that particular experimentation or observation is very close to what the population we believe, then it's considered accurate and it's low bias. Okay, but if for some reason the data material shows that it's not close to what the population seems, then that's low bias or high bias. Okay, so in other words, it's not accurate. So bias is a measure of how accurate. Variability is a measure of how precise a sample of data is compared to the population. So for instance, if we were to do some kind of surveys and the answers were all over the place and nothing centralized around one specific data value, we would call that high variability because there's too much broadness in it. Now, if in another case we conduct an experimentation or some kind of observation, we find that the data values that we collect are very centralized around a specific area, we can call that low variability. The best way to know how well a survey works or an observation or what am I looking for? Yeah, the answer is true, by the way. If we want to know how accurate and how precise a particular survey or observation or experimentation is, we look at the level of bias and the level of variability. High bias, it's not very accurate. High variability, it's not very precise. So this is true. Low bias, it is very accurate, and low variability, it is very precise. So the best way to describe this is think about the way a bullseye is shot at, okay? If you're at a gun range and you're shooting and your bullets are all over the place and they're way outside the bullseye, okay? But the average is in the bullseye, it's considered accurate because your grouping is not precise. It's high variability, but it's high accuracy, or low bias. Okay, because if you average it out, if you're all around the bullseye, but your average comes out in the bullseye, it's considered accurate. But the precision is not there because you're all over the place. Now, if you group very well, but it's all grouped around one corner of the bullseye and not in the center, it's not accurate, but it's considered what we call precise, or it's low variability. Okay, so that's what that's all about. Bias caused by members given a treatment with inactive ingredients is called control group bias. Actually, no, that's not true. Anytime someone's given something that's not has any kind of effect at all, that's considered a placebo. And if someone, a member of a group, a participant of a study, that are given some kind of treatment with inactive ingredients, a treatment with inactive ingredients is defined as a placebo. It's not called a control group bias. Even though those people are in the control group, it's considered a placebo effect. All right. Now, this one's kind of tricky. You need to think about this for a second. When asked if he served in Congress, Mr. Bias stated that he had served in Congress when he'd only served as mayor of Terre Haute. This phenomenon is called what? Okay, now this is strange, but it's two. It's called response bias. He lied. The participant lied, possibly to impress the surveyor. Could have been a possible observer effect, but, you know, if it's not just the surveyor, let's say he's getting interviewed, okay, and someone asked him if he had ever served in Congress, and he said yes, and he wasn't very clear about it, you know, he would have to walk that back. He would have to say, no, I never did serve in Congress. I don't know why I said that, blah, blah, blah. But it calls into question his integrity. And that's the whole point of it. So response bias is something that can happen. All right, now let's look at these last two questions. This is specific for lesson 10, the very last parts of that. Listen to me, I can't even talk. The very last part of that lesson, we talked about, I think that's in lesson 9. Yeah, it is. It is. Okay, so anyway, the very last two slides talk about variability, very specific stuff. Okay. Judy has dark eyes, but her cousin from Spain has light eyes. Okay, this is an example of what kind of variability. When DeKalb has tassels removed from corn stalks, they're hoping to produce a specific type of hybrid plant. This is an example of blank variability. Okay, if you look at these last 2 or 3 slides on that particular lesson, it says variability can be caused by natural variability or induced variability. Natural variability occurs with no human intervention or error. Okay, so if we look at this, Judy has dark eyes, but her cousin from Spain has light eyes. This is an example of natural variability. This happens naturally. Humans didn't do anything to change the color of her eyes. They're cousins, okay? They're similar, but they're not alike. So that's a natural variability. But when DeKalb has the tassels removed from the corn stalks, those are actual reproductive organs on a plant. They're specifically changing the way nature works. And they're hoping to produce specific type of hybrid. When they hybridize plants, that's how they do it. I should know this. My first job ever when I was 13 years old, growing up in Indiana, was detasseling corn. That's what we do. We walk down the corn rows miles at a time in 100-degree weather, pulling tassels off of corn stalks. That is an induced variability. That we change that. We make sure that it's variable because of our efforts. All right, for the last two questions, Dr. Huey, a viral vaccine design researcher, decides to randomly choose half of the participants to be given the treatment, leaving the decision which participants get the new treatment unknown to both the assistants giving the treatment to them and the participants. What two methods did Dr. Huey use to attempt to ensure accuracy of the experiment? Okay, so let's talk about this for a second. Understand the first thing he did was he randomly chose half of the participants to get a treatment. If I'm not mistaken, this is part of lesson 10. It's where the approach of the experimental designer, he's trying to ensure that the treatment group and the control group are similar, and therefore he can determine different outcomes for each. He can be more confident with his results because of this treatment. And not the differences in the participants. In other words, that's very specific. He randomly assigned the treatments. That's called random assignment of treatments. And it's really kind of funny. And the second part was he didn't let the people helping him, his assistants, know which ones were getting the treatment. And he didn't know the participants know which ones were getting the treatment. So that's called, the process of that is, it's sometimes you get participants that will inaccurately report improvement. And then you also may have researchers that are assisting them that will subconsciously try harder to find improvement in treatment group participants versus the control group. So if they know who is getting the treatment, who's not, they may, unbeknownst to them and unintentionally give bias towards the group getting the treatment and not the group getting control. So getting this to be double blind can ensure more accurate reports. And that's what it's called. It's a double blind study. So our actual answer here is called random assignment of treatments and double blind study. So there you go. Dr. Huey decided that the first study did not collect enough data to be conclusive enough to persuade the CDC of his findings. Therefore, he determined to conduct 5 more similar experiments to gather even more data to prove his evidence is conclusive. Which method did he use to improve the accuracy of his experiment? This should be very simple. If you go back and look at the lesson 10, it's simply an easy one. I think you can see it already highlighted. It's called replication. He just conducts the experiment several times so that he has ample supply of data to prove his point. So that's it for the review, folks. Shouldn't have any problems working on this for the test. This test shouldn't be too hard. Y'all get it done. In the meantime, folks, be blessed. Be a blessing.